Yep. Seems like I am live. Mhm. Mm, Yep, I am live. Stream number 5 for the C programming language by the book The C Programming Language by Brian Kernighan and Dennis Ritchie. Prentice Hall of Software Series INCC second edition. And our goal with this is to just go through with this and understand how C works, and then I have another book. Wait, let me show you this, writing a C compiler, and we will be writing our own C compiler after this book. That is the goal. Well, not exactly after this book, but after this, I will be doing some problems, some advent of code problems. Let's say about 10 advent of code problems. Let me write in Excalibur. Yep, this learning C, and then by reading R and K, Dennis Ritchie and Dennis Ritchie and Brian Kernighan, and then add-on of code, 10 to 12 problems, then WebSocket server, which will be terminal based. The front end will be on terminal and the back end will be in C, and both in C, terminal, front end and back end. And then not a transpiler but a compiler. That is going to be my C journey. Then I have other plans about learning Rust and then doing these 3 steps again in Rust to understand Rust. And why? I don't know. I just like to do it. I would like to have an idea about how things work. And this would be a good start. Yesterday we were at about, I guess, page number 46 somewhere. Huh, we had done that. Yep, we were here. Assessment operators and expressions. Let's go. An expression such as I equals I plus 2, in which the variable on the left side is repeated immediately on the right, can be written in the compressed form this: I plus equals 2. The operator plus equals is called an assignment operator. Well, plus is equals to is also an assignment, but okay. Most binary operators like plus that have a left and a right operand have a corresponding assignment operator and equal to, where OP is one of plus, minus, multiply, divide, modulus, left shift, right shift. Okay, and XOR or. Okay, if expression 1 and 2 are expressions, then expression 1, expression 2, okay, is equivalent to this. Okay, expression 1 operator, and then expression 2. Except that expression 1 is computed only once. Notice the parentheses around expression 2. Yep, I see them. This means this rather than this. Ah, okay. As an example, the function bit count counts the number of 1 bits in its integer argument. Yep. And we start from 0 till x is not equal to 0. Till x is not equal to 0. And then it makes x equal to its right shifted value. Then if and this. Okay, I take x's and with 1, which would give me the last bit. If it is 0, I would get 0, and if it is 1, I would get 1, and I will keep increasing b. And then at the end, I will return b. Okay. Declaring argument x to be an unsigned ensures that when it is right shifted, vacanted bits will be filled with 0, not signed bits, regardless of machine the program is running on. Quite apart from consciousness, An assignment operator have the advantage that they correspond better to the way people think. We say add 2 to I, increment I by 2, not take I and add 2, then put the result back in I. This is the expression I plus 2 is preferable to this. In addition, for a complicated expression like this, something and inside something plus some other thing plus some other thing, that is where this whole thing is started from here till here is the index for this thing equals plus 2. The assignment operator makes the code easier to understand since the writer doesn't have to check painstakingly the two long expressions are indeed the same or to wonder why they are not. And an assignment operator may even help a compiler to produce efficient code. We have already seen that the assignment statement has a value and can occur in expressions. The most common example is this. Yep, yep. The other assignment operators, plus equals, minus equals, etc., occur can also occur in expressions, although this is less frequent. Key. In all such expressions, the type of assignment expression is the type of its left operand, and the value is the value after the assignment. Yep. Exercise 2.9. Let's go. In a two's complement number system, x equals and of x minus 1 deletes the rightmost one bit in x. Explain why. Use this observation to write a faster version of bit count. Okay, I am taking x's and after subtracting 1 from it. If the last bit is 1, then after subtracting 1, I would get 0 there, 0, and then taking the and of that thing with x will give me the whole of x except except the LSB. But this is 2's complement number system. But then if the LSB is 0, then subtracting 1, what would that do? Subtracting 1 from 0, I will have to have a carry, which will go a borrow that will go forward and subtract if that is 0 or 1. It depends what will happen then. Deletes the rightmost one bit in x. Explain why. How does it delete the rightmost one bit? I have x, let's say, equal to 0, 1, 0, 1, 1. If it is 1, then my expression is this: x and equals x minus 1. If x is equal to this, then x minus 1 is 0, 1, 0, 1, 0. And taking its and with 0, 1, 0, 1, 1 returns 0, 1, 0, 1, 0. Essentially, the last bit is deleted in a way since it was 1 and now it is 0. But if the last bit is, let's say, the x is 1, 0, 1, 1, 1, here also 1, and then 0, and then also 0. If I subtract 1 from this, then I will get subtract from this 1, 1, 0, 1, 1, 0, 1. And now if I take its and, I will get 1, 0, 1, 1, 0, 0, 0. Shit. Last three bits got deleted. So why is it saying that? the rightmost one bit in X. This deletes the rightmost one bit in X. In a 2's complement number system. 2's complement number system. 2's complement. But it does not matter if it is 2's complement or not. What matters is if it is even or not. If it is odd, then the last bit becomes 0, and if it is even, then more than last bit becomes 0. Let's say it is 2's complement, right? Then subtracting 1 would be equal to adding 1's complement. Let's say this is our X. This takes 1, 2, 3, 4, 5, 6, 7, and 8. This takes 8 bytes. And then, yep, this takes 8 bytes. And then to subtract 1, well, I can simply do that. 0, 1, 1, 1, 0, 1, 1, 1. And if I take the AND of these two, I will get 0, 0, 0, 0, 1, 1, 0, 1. The last 4 bits got deleted. These were the original bits, and these zeros are the ones that I got. So more than 1 is being deleted. So what does this mean? Let me see. Here, what does the question mean by the bit being deleted? What does the question here mean by bit being? The phrase deletes the rightmost bit means that operation this turns the rightmost bit in X into a 0 while leaving all other bits unchanged. Well, it is not leaving all other bits unchanged. It is changing these extra bits if the number is even. Yep, if the number is even like this, then yep. And if you take their and, notice how every bit after the rightmost flips. Wait, is this the exact number that I took? Nah, 1010 1011 111. I just added this extra one, otherwise this would have been the same example test number which ChatGPT took. That would have been really crazy. The AND operation results in, yep, general rule. See, but yes, I got the rightmost one bit, deletes the rightmost one bit, one. The rightmost one bit. This one, this one becomes 0, like here in this. Okay, the rightmost one bit becomes 0. Okay, that makes sense. That makes sense because to satisfy this minus 1, the borrow will keep going forward till there is a minus 1, till there is a 1 in the sequence, and when it encounters a 1, it will turn that 1 into a 0 and everything before it into a 1. And if I take its and, then it will become 0 because the signs have become opposite. Okay, now let me use this observation to write a faster version of bit count. A faster version of bit count. Go to C folder, CD chapter 2 and bit count. Count 1 bits.c. Include stdio.h int main and int the bit count will take in an sign x an signed sign gned. Okay, integer bits equal 0 and for nothing while x is not equal to 0. Keep doing this. If x, I want to get x is less b. This function, this thing, can turn the rightmost bit in x by 0. Ah, shit, that makes sense. That makes sense. I will not have to do the if statement. X and equals x minus 1. And every time I do that, I will make bits plus plus and in the end return bits. Now let me printf the number of bits in some number is some number and in some number is some number and in some number is some number. The new line and then the bits 5 and let's say 15 and let's say 60 60. Let's see, clang count bits, send the output to dot out, nope, out like that, dot slash out, and number of bits in 5 is 5. Oh, my bad. I had to call the function on them. Here, bit count. Instead of 5, it should be 150. Oh no, shit. 15. 60 and now this should work. In 5 I only have 2 bits, in 15 I only have 4 bits, in 60 I have only 4 bits, in 5 I should have actually 4 plus 1 2. Yeah, that is correct. 4 like 4 plus 1 is 5 and since I have 4 and 1 so that is 2 number. If I do 7 instead of 5 then I should get 3 as the answer. Yep, 3. Conditional expressions. The condition if this, then this, if this. This is considered true if this expression evaluates to a non-zero. Compute in x. That was two. I'm right. Compute in x the maximum of a and b. The conditional expression written with the ternary operator provides an alternative way to write this and similar construction in the expression this, if this is true, then return this value, otherwise return this value. Then x equals this question mark a semicolon b, this question mark a semicolon b. The expression 1 is evaluated first. If it is non-zero true, then the expression 2 is evaluated, and that is the value of the conditional expression. Otherwise, expression 3 is evaluated, and that is the value. Only one of expression 2 and 3 is evaluated. Thus, to set z to minimum of a and b, do this. If a is greater than set to b, then set to a, otherwise b. Max. Yep. It should be noted that the conditional expression is indeed an expression, and it can be used wherever any other expression can be. If expression 2 and 3 are of different types, the type of the result is determined by the conversion rules discussed earlier in this chapter. For example, if f is a float and n is a int, then the expression f is a float and n is a int is of type float, regardless of whether n is positive. Okay. Parentheses are not necessary around the first expression of a conditional expression, since the precedence of this is very low, just above assignment. They are advisable anyway. However, since they make the condition part of the expression easier to see. The condition expression often leads to succinct code. For example, this loop prints n examples elements of an array 10 per line, with each column is separated by one blank, with each column separated by one blank, and with each line, including the last, terminated by a new line, with each column separated by a blank. 10, 10 per line, with each column separated by one blank, and each line, including the last, terminated by a new line. New line at the end. Ah. So first of all, print a new digit, a 6-digit number, which is the element, and then a character. And what is the character? If I remainder equal to 9, or I equals n minus 1. Okay, if I have either reached the end of a line, like here, or the end of all the elements that exist, then I will print a new line, otherwise I will print a space. A new line is printed after every 10th element and after the nth, and after the nth. All other elements are followed by one blank. This might look tricky, but it's more compact than the equivalent if else. Although a good example is this. You have d items, the new line, and is the number, and well, you have already written ms there, so why do you want to print two s's there? Exercise 10. Rewrite the function lower, which converts uppercase characters to lowercase with a conditional expression instead of if else. Lower.c here includes stdio.h dot h and main, and then implementation of to lower. Now, does it return a string? Rewrite the function lower, which converts uppercase to lowercase. It converts, so let's say it does not return and takes in a char pointer. Yep, char pointer stir and converts it to lowercase. How does it do it? For int I equals 0, I not equal, but stir I is not equal to null character and I plus plus. And what do we do here? We see if I is uppercase or not. How do we see that? No, not uppercase. I'll see if it is lowercase. If, but I don't have to use if. Stir I equals to stir I greater than equal to 97, which is the code of for capital for small a. If it is greater than that, then I will just give a stir I. Otherwise, oh shit. Otherwise, I need to give it a lower form. I need to convert it to its lower form. And supposing I am only getting alphabets. Supposing that I am only getting alphabets, then what do I do? I do str I plus 97 minus 65, or I can just write a minus a. Okay, character array equals hello. This is a string. Printf %s, that is, it is a string, and pass it to lower and do that. Shit. Lower argument to void is incomplete. Oh, 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 oh. This will work. Clang to lower. What the heck? To lower dot c and put the output to out dot out. Well, I gave it a lower string, so that is what it will print. What if I write everything in uppercase? Let's see, it should convert it into lowercase, and that it does, as function with. Now, precedence and order of evaluation. Table 2.1 summarizes. Shit, I was reading at too big of a font. I think I was reading at this big of a font. That is bad. This is good, but you guys might not find it good. So, this is what I will go with. Table 2.1 summarizes the rules for precedence. Maybe this for you guys. Table 2.1 summarizes the rules for precedence and associativity associativity of all operators, including those that we have not yet discussed. Operators on the same line have the same precedence. Rows and rows are in order of decreasing precedence. So this is higher precedence and lower precedence. Whoa, whoa, okay. And right to left. Right is high precedence and left is low precedence. Or it is written. Associativity, how associativity is described. Precedence is the order of evaluation, and associativity is the order of evaluation when the precedence is same. Operators on the same line have the same precedence. Rows are in order of decreasing precedence. So, for example, multiply this, all have the same precedence, which is higher than the binary plus and minus. The operator, this refers to function call. The operator this and this are used to access members of a structure. They will be covered in chapter 6. We are only at chapter 2. With size of an object, chapter 5 discusses multiply indirection through a pointer. Oh, okay. And add an object. And chapter 3 discusses the comma operator. Shit, comma is an operator in of itself. That is crazy. Now, what do we have here? All of these side of yep, unary and plus minus and this have higher precedence than the binary forms. Yep. Note that the precedence of the bitwise operator this falls below equals and is not equal. This implies that bit testing expressions like this must be fully parenthesized to give proper results. C, like most languages, does not specify the order in which the operands of an operator are evaluated. The exceptions are and or this for example in a statement like this, F may be evaluated before G or vice versa. Thus, if either F or G alters a value on which the other depends, X can depend on the order of evaluation. C, like most languages, does not specify the order in which the operands of an operator are evaluated. The order in which the operands of an evaluator, the order in which the operands of an evaluator are evaluated, operands of an operator are evaluated. The expressions this, for example, in a statement like this, I do not know either F or G will be evaluated first. F may be evaluated before G or vice versa. This, if either F or G alters a value on which the other depends, X can depend on the order of evaluation. Immediate results can be stored in the temporary variables to ensure a particular sequence. That also makes sense. Similarly, the order in which function arguments are evaluated is not specified. So the statement, the order in which function arguments are evaluated. Okay, so in this we do not know what will happen first. This can produce different results with different compilers depending on whether n is incremented before power is called. Yep, the solution is of course to write plus plus n so that uh, first I get the value of n, and after getting the value n is incremented. Oh, like, but still the incremented n could be passed on to the power function to get its square, the square of the incremented value. So still doesn't make any sense to write it here. Printf and then this. Function calls nested assignment statements and increment and decrement operators cause side effects. Some variable is changed as a byproduct of the evaluation of an expression. Some variables are changed as in byproduct of the evaluation of an expression. In any expression involving side effects, there can be subtle dependencies on the order in which variables taking part in the expression are updated. One unhappy situation is typified by the statement this. Okay. Function calls nested assignment statements and increment and decrement operators cause side effects. That is, they have effects which outlast the functions themselves. Some some variable is changed as a byproduct of the evaluation of an expression. In any expression involving side effects, there can be subtle dependencies on the order in which variables taking part in the expression are updated. One unhappy situation is typified by this. The question is whether the subscript of the old value of I or the I think the old value. Compilers can interpret this in different ways and generate different answers depending on their interpretation. The standard internationally the standard intentionally leaves much more matters unspecified. When side effects assignment to variables take place within expression within an expression within an expression is left to the discretion of the compiler, since the best order depends strongly on machine architecture. The standard does specify that all side effects on arguments take effect before a function is called, but that would not help in a call to print above. Yeah, right. The standard does specify that all side effects on arguments take effect, take effect before a function is called, but that would not help in the call of printf power. Okay, the moral is that writing code that depends on order of evaluation is bad programming practice in any language. That makes sense, except you explicitly know how the operands, the expressions for an operand are going to be evaluated. The order is explicitly known, example in the ternary operator. Naturally, it is necessary to know what things to avoid, but if you don't know how they are done on various machines, you won't be tempted to take advantage of a particular implementation. You won't be tempted. And now, question 3, control flow. And how long is this chapter? Fuck, reading it like this. The control flow of a language specifies the order in which computations are performed. We have already met the most common control flow constructions in earlier examples. Here we will complete the set and be more precise about the ones discussed before. And there is a reason that if you are reading a smaller font, then it is better, because to read a smaller font, you have to focus more. Thus, you are paying more attention, and thus you are more likely to understand what the heck you are reading. That is just one thing I learned about 10 minutes ago. Okay, this chapter is just 9 lines long. Maybe we got this. And I don't think that there are any, yep, there are about 6 questions. Okay, and what is the time? Only 40 minutes. I guess we got this. Maybe. Well, my goal is that, but we'll see. We'll see. We will see. Yep. Well, we are not going to read it like that in that small of a font, but this one which is good. The control flow, yep. Statements and blocks. What are statements and blocks? An expression such as x equals 0 or I plus plus or printf becomes a statement when it is followed by a semicolon, as in, okay, they become a statement when it is followed by a semicolon. In C, the semicolon is a statement terminator and rather than a separator, as it is in languages like Pascal. Braces are used to group declarations and statements together into a compound statement or block so that they are syntactically equivalent to a single statement. The braces that surround the statements of a function are one obvious example. Braces about around multiple statements after if, else, while, or for are another. Okay, the braces that surround the statements of a function are one obvious example. Braces around multiple statements after an if, else, while, or for loop are another. Various variables can be declared inside any block. We will talk about this in chapter 4. There is no semicolon after the right brace that ends a block. Okay, so inside braces that there can be multiple statements and those multiple statements will be considered a single statement or you can call it a block. But there is one thing that I don't get, that statements and declarations. Declarations are also statements, right? In the C programming language, declarations are also statements, right? I guess yes. Yes. Well, why would I guess it is? Yes, in C, declarations are also considered statements. However, there are some nuances to keep in mind. Declarations as a statement. So declaration in C such as this is a valid statement because this is because C standard allows declarations to appear as statements within blocks inside functions. Okay, it allows declarations to appear as statements. So declarations are not statements. Declarations are a type of statements, right? Or is declaration a different concept which can be expressed as a statement? And a statement is a C specific thing, and declaration is a general thing within blocks. Here, int A equals 10 is a declaration statement. C89 and C declaration must appear at the beginning of a block. Must appear at the beginning of a block. But this is not allowed in C89. We cannot declare afterwards. Not allowed in C89 declaration after a statement. C99 and later allows mixed declarations. So this is valid. Declaration versus expression statements. Declarations introduce variables and their types. Expression statements perform computation or actions. ALU. Function declarations are not statements. Yep. A function declaration prototype or a statement. It is a part of external declarations in translation unit. However, a function definition contains statements inside it. Yes, C declaration inside. My bad. Me is sleepy. Me should not be sleepy. But they behave differently from the expression statements. Also, function prototypes are not statements. Okay. Can I find a way through which I can make this PDF black and white? It is black and white, but can I make the background black? I have an extension, but yep, that won't work. PDF in dark mode. Ah, you can read PDF in dark mode using Adobe Current Chrome or Night. How can I do that? Install dark mode PDFs for extension. Chrome Web Store. Dark PDF dark mode. Chrome Web Store. Okay, that is crazy. Extension. Where is it? Yep. Does it not work? Let me refresh. Shit. It is not working actually. Remove your add to Chrome. Let me open another file, and it is also not working. Another file, and that is also not working. Another file, and that is also not working. Dark mode PDF. PDF dark mode, PDF dark mode. This one has 11 downloads. This one has 1.1K downloads. But that is not for PDF. This one is not for PDF, it seems. Yep, this is not for PDF. Well, of course, it is for Wikipedia or something like that. Shit. I have two of them on. Nope. This. Oh, shit. No, not this. Where is it? Dark mode for Chrome. Off. Do not turn it on this website. Yep. But when you are on Wikipedia, turn it on automatically. It is on, right? Wait. Um, video dark mode. How about this one? Add extension. Let's see if it works. Uh, PDF dark mode. No, no, no. Nope, not working. How to read? No, no, no. Read in dark mode in Chrome. Night PDF. Install Night PDF on Linux. Nope. I will not do that. Use PDF dark mode extension for Microsoft Edge. PDF in dark mode in Chrome. Install a Chrome extension to enable that. But that is not working, is it? Dark mode for optimized white background instantly transform your PDF reading experience in Chrome with dark mode PDF designed specifically for documents with predominantly white backgrounds. This extension seamlessly PDF. Okay, but this is not working. Invert. I can invert it, right? Add invert. Let's see if invert works. Right. Invert. Where is it? Yep. It does not seem to be working. Okay, we will just read as it is. I will look for it on my own afterwards. Remove from Chrome. Yep. Shut up. I removed you, so just get removed. Remove. And this also remove. Going to work in. This also remove this. Yep. Anyway, where were we? We were at here. Yep. 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 If else. The if else statement is used to express decisions formally. Formally, the syntax is this: if expression, then this is statement, else this is statement. Where else part is optional, the expression is evaluated. If it is true, then expression, then statement one is executed. Otherwise, if it is false, then statement two is executed. Since an if test, the numeric value of an expression containing coding instruction shortcuts are possible. The most obvious writing is this. Instead of yeah, we can write this instead of this not equal to 0. Sometimes this is natural and clear. At other times it can be cryptic. Because the else part of an statement if else is optional, there is an ambiguity when an else if omitted from a loop nested if sequence. This is resolved by associating the else with the closest previous else less if. For example, in this, if else if this else will be with this else. The else goes to the inner if as if we have shown by indentation. If that wasn't what you want, braces must be used to force the proper association. Braces and then else. Okay. The ambiguity is especially pernicious in situations like this. If ah shit, this is shit. What the heck is this? This is this is hard to know. Okay, let me see where this would belong. I guess this would be this else would be a part of this if because that is the one coming before it. But this could also be part of that one. But yeah, this will be a part of this one. The indentation shows equivocally what you want, but the compiler doesn't get the message and associates the else with the inner if. This kind of bug can be hard to find. It is a good idea to use braces when there are nested ifs. By the way, notice that there is a semicolon after z equals a. Where is z equals a? Here, semicolon. In this is because grammatically a statement before the if follows the if and an expression like a statement. This is always terminated by a semicolon. Okay. Else if the construction if else if else if else occurs so often that it is worth a brief separate discussion. This sequence of if statements is the most general way of writing a multi-way decision. The expressions are evaluated in order. If an expression is true, the statement associated with it is executed, and this terminates the whole chain. As always, the code for each statement is either a single statement or a group of statements in braces. In this, yep. The last else part handles the not the above or default case when none of the other conditions is satisfied. Sometimes there is no explicit action for the default. In that case, the trailing else if else can be omitted or it may be used for error checking to catch an impossible condition. Yep. To illustrate a three-way decision, here is a binary search. What the heck? Binary search function that decides if a particular value x occurs in the sorted array y. The element of v must be increasing order. The elements of v must be in increasing order. The function returns the position a number between 0 and n minus 1. Number between 0 and n minus 1, that is the index for the element x in the array v. If x occurs in v and minus 1, if not. Binary search first compares the input value x to the middle element of the array v. Hmm. Yep, it binary search first compares the input value x to the middle element of the array v. If x is less than the middle value, searching focuses on the lower half of the table, otherwise on the upper half. In either case, the next stop to compare x to the middle element of the selected half. This process of dividing the range into continuous unit continues until the value is found or the range is empty. It will take an integer that is the range and array and then the number that is to be found. Initially low equals 0 and mid is high is n minus 1 and mid is low minus high by 2 till low is less than equal to high. Mid equals low plus high by 2. Mid is low plus high by 2. And then if x is less than mid, then make high equal to mid plus 1. That is, the element is to the right, is to the left. If x is greater than mid, then the element is to the right. Therefore, low equals mid plus 1. Else, I found the element. Return mid. Else, return minus 1. That is, I did not found the element. The fundamental discussion is whether x is less than, greater than, or equal to the middle value we made at each step. This is natural for else if our binary search makes two tests inside the loop when one would suffice at the price of more tests outside. More tests outside. Write a version with only one test including the loop and measure the difference in runtime. How can I do this in one test? Our version makes two tests inside the loop when one would suffice. This test and this test. Add a version with only one test inside the loop and measure the difference in runtime. How can I make this function run with only one test? How can that happen? Hmm. Here I have two tests. One is this and the other is this. How can I make it so that only one of them can suffice the whole procedure? How can that happen? So that I have to figure out a test which can tell me. Hmm, hmm, I have to check if the number is higher, if the current mid is higher than the target, lower than the target, or equal to the target. If it is equal, then I exit. If it is not equal, then I don't exit. At the price of more tests outside. More tests outside. Like I can add a test here. Let's see. No, not no copying. Make new directory chapter 3 3 dot 3 dot nothing. Should I misspelled it? Move char upper 3 into chapter 3 cd chapter 3 and binary search dot c include stdio dot h int main and inside I have int binary search. It will take x which will be a target, then integer array, and then a number which will tell me the size of the array. Now let start, mid, end, and start equals 0, end equals n minus 1, and while start less than equal to less than cannot be equal to, can it be equal to, yep, it can be equal to end. What do I want it to do? Mid equals start plus end whole divided by 2. What? Oh, int. There is nothing, no such thing as and let and a semicolon here. Return -1 here. Okay, if mid. Hmm. How can I suffice this in only one test? If the middle element is greater than what I want, yep, then I want to decrease the end. Otherwise, if it is higher, if the middle element is higher than what I want, if the middle element is greater than I want to decrease the end, and if it is lower than what I want, then I want to increase the start to mid +1. But I want to get out of the loop if the mid element is equal to the target. And when will that happen? When will the mid element become equal to the target? Mhm. When will the mid element become equal to the target? When I have found the element, but I want to exit this while loop when I have found out. Maybe in here I can do it. While this and air mid is not equal to x, mid equals start, nope, start in, not into plus, start plus end by 2. Yep, that seems like it. And here do something like if mid is greater than x, if mid is greater than x, then end equals mid -1, else start equals mid +1. And in the end, don't return just 1, return x array mid. Check if array mid equals to x, and if it is, then return mid, otherwise return -1. Now this should work, I guess. That is not the way. Int air equals 1, 2, 3, 4, 10, 165, 6 this. Okay, and then print answer by the binary search function is %d, and then new line is binary search and given air. Too few arguments. Oh, yep, there are too few arguments. What do I want to look for? I want to look for 165. And how many elements are there? There are 1, 2, 3, 4, 5, 6 elements. Node, nope, not node, lang binary search and put the output out -1. I did not find it. That is just crazy. I should have found it. So here I got x equals, oh, I wrote 164 instead of 165. Let's see. I guess the answer should be 3, 4. Yes, it is 4. So yep, the function is working correctly. Now switch statement. The switch statement is a multiple decision that tests. I am in the center of the screen, right? Yep, I am. And stream is also not stuck. That is a good thing. Yep, not stuck at all. Working just fine. And these are my other channels. If you want to go out and seek and some other videos and playlists. Crazy stuff. The switch statement is a multi-way decision that tests whether an expression matches one of a number of constant integer values and branches accordingly. The switch statement is a multi-way decision that tests whether an expression matches one of a number of constant integer values and branches accordingly. Okay, switch expression and inside semicolon, then case constant expression statements, case constant expression statements, default and statements. Each case is labeled by one or more integer valued constants, by one or more integer value constants or constant expressions. If a case matches the expression value, execution starts. Execution, execution starts at that case. All case expressions must be different. The case labeled default is executed if none of the other cases are satisfied. A default is option if it isn't there, and if none of the cases match, no action at all takes place. Cases and the default causes can occur in any order. In chapter 1, we wrote a function to count the occurrences of each digit, white space, and all other characters using a sequence if. You see sequence of if else. Here is the same program with a switch while c is not equal to 0. Switch c, case 0, case 1, case 2, case 3, case 4. Okay, for any of these cases, do this and then break. And for case this, space, new line, or tab, increase new line and then break, and default no number of other, increase it and then break. The break statement causes an immediate exit from the switch because cases serve just a label after the code. For one case is done, execution falls through the next unless you take explicit action to escape. Because cases serve just as labels. Just as labels. Okay. Execution falls through the next unless you take explicit action to escape. Break and return are the most common ways to leave a switch statement. Break statement can also be used to force an immediate exit from while, for, and do loops, as will be discussed in this later chapter. In late Discussed later in this chapter. Okay, some things I don't understand. Following through cases is a mixed blessing. On the positive side, it allows several cases to be attached to a single action, uh, as with the digits in this example, but it also implies that normally each case must end with a break to prevent falling through the next. Falling through from one case to another is not robust, being prone to disintegration when program is modified. When the exception of multiple labels for a single computation falls through should be used sparingly. Wait a minute. Yo, I got some carrot juice. That is crazy. Falling through cases is a mixed blessing, not robust, being prone to disintegration when the program is modified, with the exception of multiple labels for a single computation. Fall through should be used sparingly and commented. As a matter of good form, put a break after the last case, the default here, even though it's logically unnecessary. Someday, when another case gets added at the end, this bit of defensive programming will save you. Yep. Why is Linus Torvald on my home screen? Okay, in C language, the switch statement when a case turns true, does that mean that all the statements after that case will run? That all the statements after that case will run, even if some statements are not under the case which turned out to be true. Yes, and see the switch statement exhibits full fall through behavior unless explicitly controlled with break. How it works: when a case statement matches switch expression, execution begins from that case. If there is no break statement, execution continues sequentially in the next case and next and so on until a break statement is encountered. Okay. Question number three: write a function escape st that converts characters like new line and tab, visual escape sequences like n and t, as it copies the string t to s. Use a switch. Write a function for other directions as well, converting escape sequences into real characters. That is pretty goddamn easy. Escape to visible dot c stdio int main escape won't return anything. Ah shit. Escape char from s target. Oh, t means target and char s means source. That makes sense. For int I equals 0 till si is not equal to null, do something like this I plus plus, and then inside switch si. Not only I will need another integer j equals 0, which will tell me in at what place I am in the string t. So switch s case new line. What will happen in new line? tj degrees tj equals backslash and then increment j after then tj plus plus equals n. Yep, and now I have to do that and also break. Case tab feels like a parser. No, copy these, print here, and here instead of n, it should be t. It should be t like that, and then here now check for t b. Check for space and put b here, and then check for what do I want to check for now? What are the other escape sequences that can occur? I don't know. I will go back to default where tj degrees plus plus equals what equals si and yep, that is it. And now char t, how many characters do I want? 100 and char s pointer s, it can be a string literal. It's going to be hello world to these and then a new line, and then 4, copy that, go back up, and 6 here, escape with t comma s, and then print them both one by one, print s, which is going to be literally s, and then printf, which is going to be t. Clang escape, the output goes dot out, and that is correct. The function works, this one. Now, loops, while, and for. Yep, my lips are becoming redder. It is the carrot juice. We have already encountered the while and for loops in while expression and statements. The expression is evaluated if it is not non-zero statement is executed and expression is re-evaluated. This cycle continues until expression becomes zero, at which point execution resumes after a statement, whatever is after a statement. The for statement, this expression statement is equivalent to expression 1 while expression 2 and a statement, and at the end expression 3. Okay, except for the behavior of continue, which is described in section 3.7, which is kind of like the opposite of break whenever encountered inside a loop brings you out of the loop, but continue makes you continue the loop, but with whatever your iterator is. It starts the loop from the top with the iterator being increased by 1. Like whatever you are doing in the expression 3 in here, if it is a for loop, then expression 3 is executed and then the loop starts again, and that is that. Grammatically, the three components of a for loop are expressions. Most commonly, expression 1 and 3 are assignments or function calls, and expression 2 is a relational expression. Any of the three parts can be omitted, although the semicolons must remain. If expression 1 and 3 is omitted, it is simply like this dropped from the expression. If the test expression 2 is not present, it is taken permanently. It is taken as pre permanently true. So this is an infinite loop, presumably to be broken by other means such as break or return. Whether to use while for, or for is largely a matter of personal preference. For example, while equals this or this, skip white space characters. There is no initialization or reinitialization. So the while is most natural here. Now, the for is preferable when there is simple initialization, and increment, since it keeps the control loop control statements close together and visible at the top of the loop. This is most obvious in for int I equals I less than n and I plus plus, which is the C idiom for processing the first n elements of an array, the analog of the Fortran do loop or the Pascal for. The analogy, when were these languages made? When was Pascal made? 1970. Okay. When was Fortran invented? 1957. That is crazy. This is some Fortran code, I'm supposing. This is Fortran. Yeah, looks like C++. And why does he look like someone dangerous? Like Victor Bout. Okay, yep. Coming back to our thing. The analogy is not perfect, however, since the index variable I retains its value when the loop terminates for any reason, because the components of the for are arbitrary expressions. For loops are not restricted to arithmetic progression. Nonetheless, it is bad style to force unrelated computation into the initialization or increment of a for, which are better reserved for loop control operations. As a large example here is as a larger example, this is pretty large shit. I cannot even see the end of it. As a larger example, here is another version of ATOI, ASCII to integer, for converting a string to its numeric equivalent. A string to its numeric equivalent. This one is slightly, yeah, if the string is a string of characters, that is. If the string is a string of numbers, that is. This one is slightly more general than the one in chapter 2. It copies with the option leading white spaces or an option plus minus sign. Chapter 4 shows an ATF which does the same conversion for floating point numbers. That is crazy. And the structure for the program reflects the form of the input white space, skip white space if any, get sign if any, get integer part, and convert it. Okay, each step does its part and leaves things in a clean state for the next. The whole process terminates on the first character that could not be part of a number. Okay, that makes sense. Int I and sign for I equals 0 is space si plus plus skip white spaces do nothing. Okay, now I points to the first character that is not a space. Then sign equals I si equal minus one. If it is, then sign becomes minus one. Otherwise, it becomes one. If si equals plus uh, 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 if si equals plus or minus one, then make it point to the next character. Otherwise, for n equals 0, starting from 0 is digit. Do the is digit part with si and then increase I and keep adding it to n and at the end return n when it is not a digit. Okay, standard library provides a more elaborate function stir to L for conversion of strings to long integers. The The advantages of keeping loop control centralized are even more obvious when there are several nested loops. The following function is a sort, shell sort for sorting and shell sort for sorting an array of integers. The basic idea of this sorting algorithm, which was invented in 1959 by DL Shell, is that in early stages, far apart elements are compared rather than adjacent ones, as in a simpler inter change sorting. This tends to eliminate large amounts of disorder quickly, so later stages have less work to do. The interval between compared elements is gradually decreased to one. Yes, okay. At which point the sort effectively becomes an adjacent interchangeable method. Okay. Shell sort is a sorting algorithm, but that is the thing, right? I'm not here learning algorithms. I'm here for the C language. For algorithms, I have something else. But here I am for the C language and I will be learning algorithms. I want to finish this book as soon as I can because after that, I have quite a bit of stuff to do. I have to do not assembly. I have to do advent of code about 10 questions, at least 10 questions of advent of code of any year. And then after advent of code, I have to do shit, make a web socket server where people can join and exit, and also mm, make a front end for it, terminal based front end, so people can actually join. Ah, foo, 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 foo. That would be crazy. I would have to send and receive requests in C. I don't know how to do that, but that would be cool. There are here I have four, one, two, three loops. There are three nested loops. The outermost controls the gap between compared elements, shrinking it from n minus 2 by a factor of 2 each pass until it becomes 0. Okay, the middle loop steps along the elements. The innermost loop compares each pair of elements that is separated by gap and reverse any that are out of order. Since gap is evenly reduced to 1, all elements are eventually ordered correctly. Notice how the generality of the for loop makes the outer loop fit in the same form as the others, even though it is not an arithmetic progression. Even though it is not an arithmetic progression, we can still work with it as if it were an arithmetic progression. Okay. One final C operator is the comma, which most often finds use in the for statement. A pair of expressions, comma. and comma. A pair of expressions separated by a comma is evaluated left to right, and the type and value of the result are the type and value of the right operand. The type and value of the result are the type and value of the right operand. Thus, in a for statement, it is possible to place multiple expressions in the various parts. For example, to produce, to process two indices in parallel. This is illustrated in the function reverse s, which reverses the string s in its place. Starting from one index starts at 0 and the other at the end till I less than j. Keep increasing I and decreasing j. Use a temporary variable to store it and then switch them apart. Okay, the commas that separate function arguments, variables in declaration, etc. are not comma operators and do not guarantee left to right evaluation. Okay, 30 minutes. Operators should be used sparingly. The most suitable uses are for constructs strongly related to each other, as in the for loop, in reverse, and in macros, where a multi-step computation has to be a single expression. A comma expression might also be appropriate for the exchange of elements in reverse. For the exchange of elements in reverse, where the reverse, like, oh, oh, exchange of elements in reverse. C, uh, okay, C gets the value of Si, and then Si gets the value of Sj, and then Sj gets the value of C. That also makes sense. Exercise number 3. Guess my lips are getting redder. Yes, question number 3. Write a function expand S1 S2 that expands shorthand notations like A to Z in a string S1 and equivalent complete lists this in S2. Okay, the shorthand is in S1 and I have to expand it into S2. Allow for letters of either case and digits, and be prepared to handle cases like this and this and this. Arrange that a leading or trailing is taken literally. Okay, okay. Expand, expand range.c, include stdio.h and int main here and now here. Expand s char s1 and char s2 and here this. Now I will like to have I, j, at least two of them. One will loop through the string s1 for I equals 0. S1 I is not equal to, yep, null, and then I plus plus, and then here what do I have here? Yep. Now in I will keep getting elements, right? Yep, I will keep getting elements. What are the cases that I want to handle with? Okay, I will start and I will see a character. And when I see a character, I will look for something like this after it. Whenever seeing a character, I will look. Okay, whenever I see a character, I know that it is going to be the first character in the range, and then I expect to see a hyphen, and then I will see for the character after the hyphen. Yep, character after the hyphen. That will be my um, end range, and then I will start a loop from the starting to the end character and keep adding those strings in the S2, and then the next time I will point to the end. Okay, if yes, see if S1 I is not equal to hyphen. I do not want to increment here. Is not equal to hyphen. Then I know that I have character. Then I would like to see if S1 now after a character, what do I expect to see? It can either be a hyphen or end. If Si plus 1 equals hyphen, then I will handle that case here. And else, shit, it can also be another character. In which case, else, in which case, if the next one can also be a character or it can be end or the string. Ah, yeah. So let me handle the case for this. When it is a hyphen, when it is a hyphen, then I will put j equals I, not I, but j equals s1 I, and for let not j. Shit, I need another thing here. I, j, and k. Let's say, and k will start at 0. Not let is nothing. And so I would put, yeah, that j equal to the character for and the limit. I also need to find the limit. Shit. L. The limit would be L equals S1 I minus S1 I plus 2. That is the next character. And now starting with K, not K, but um J less than L, and let me put L equals, wait, I don't need it, J less than S1 I plus 2 and J plus plus. Okay, 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 okay. And what now? This J++ and also K++. And then S2K equals J. I am adding element when I am at a character, and the next character after a character is a hyphen. But if it is not a hyphen, then it can be either end of the line or it can be end of the line or it can be another character. So what do I do in that case? I guess in that case I can just leave it. If the current is not a character. Okay, and then after it, what do I do after incrementing stuff? Yep, I guess I can just increment I plus plus. Can I? Can I? Can I do that? Uh, let's see. I guess this might work. This might just work. Char char pointer s1 equals a to z. That is not the correct format. Now char 2 is a string which has 100 spaces, and then I would like to expand s1 to s2 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 and then printf %s with the new line s2 will be that the clang expand dot slash out. I did not got z, but I got everything else. Clang. So for getting z, I should make this less than and equal to s. What will happen there? Got everything I wanted. Z and then 0 to 9. Let's see. That might work. As function yet. It works. No. Something more complicated. This and then after this A to Z again. Will this work? Okay, this worked, but partially I got Z, but after Z I got this. What the heck is this? That was not a chance occurrence. Something happened. Oh, I went out of scope. I went out of scope. Yep. Let me increase the number of characters to 150. It's functioning. It works now. Wait. How is it working? Because I'm not putting anything at the end. I should. So I am increasing K, but then at the end I should put a new line character, right? Yep, S2 K equals not new line but null character. And now it works. So were there spaces in here after this? Nope, nope, they're the same. Yep, that is correct. It works. Now 3.6 loops do while loop. And yep, how long is it? Have we got this? One, two, huh? One, two, three. I think here are three questions. Let's see what the fuck happens. Loops do while. As we discussed in chapter 1, the while and for loops test termination condition at the top. By contrast, the third loop in see the do while loop tests at the bottom, that is post test, making each pass through the body. The body is always executed at least once. The syntax of the loop is this. The statement is executed, then expression is evaluated. If it is true, statement is executed again, and so on. When the expression becomes false, the loop terminates, except for the sense of the test. Do while is equivalent to Pascal repeat until statement. Okay, well, like I know Pascal. Experience shows that do while is much less used than while and for. Nonetheless, uh, nonetheless, from time to time, is it is valuable. It is valuable as the following function: integer to ASCII, which converts a number to a character string, the inverse of ATOI, ASCII to integer. The job is slightly more complicated than might be thought at first because the easy methods of generating the digits generate them in the wrong order. We have chosen to generate the strings backward, then reverse it. Okay, ITO, it takes in a number and converts it into a string. Okay, takes in a number and then converts the number into a string. Mhm. This I and sign, it takes in a number and a place to put the string in. If sign less than n, what is sign? Sign, oh, sign equals to n. What is n? N is the number. Is less than 0, then n equals minus 1. Minus n. Oh, okay. Thus we make it positive. And then I equals 0 to this generate digits in reverse order. S. The last digit plus 0, okay, to get the digit, and then put it in the ith place. Okay, makes sense. While n is greater than 0. Okay, that also makes sense. If sign less than 0, then put a negative sign at the end and then put this and then reverse the string. That also works. The do while is necessary or at least convenient since at least one character must be installed in the array. Must be installed in the array even if n is 0. Yeah. We also used braces around the single statement that makes up the body of the do while, even though they are unnecessary, so the hasty reader will not mistake the while part of the beginning of the while loop. Oh, a hasty programmer. Example 3.4, exercise 3.4. In a 2's complement number representation, our version of ITOA does not handle the largest negative number, that is the value of n equal to this word size minus 1. This explain why not. modify it to print the value correctly, regardless of the machine on which it works. Okay, in a number, in a 2's complement number representation, our version of ITOA does not handle the largest negative number, that is this. Why does it not handle the largest negative number? Because when we make it positive, then that absolute value becomes 0. Okay, the thing is, because in a 2's complement representation, the amount of negative numbers that can be represented is one more than the amount of positive numbers. Therefore, the largest negative number, that is the least negative, the most negative number, when we are converting it into the positive number, it actually overflows and it becomes something else. I think it will become minus when we try to make it positive. I think it will become it will give us problem. It will, because there is no way that we can represent that largest negative number as a positive number. Explain why this, why not? Yes, I just explained it. And modify it to print that value correctly, regardless of the machine on which it works. How can I print that number correctly? How? If the number is negative, only then I have to put care, and care only needs to be put on in this at in this position when I am turning that negative number into a positive number, but there are not enough ways to represent the positive numbers that I can represent this huge ass negative number as a positive number. So what can I do then? Okay, write the function eat your b converts the integer into base b character representation the string s in particularly this format as a hex. Okay, write a conversion of. How can I do that? How can I handle very large negative number? Wait, let me write it. Number to string dot c. So first include stdio dot h and then int main, and then I will have my would not return anything, just take an integer to ASCII, and it would take in an integer n and character pointer s. And now the function begins and int I and sign gene sign. If si gene sign equals n less than 0, that is it is negative, then I make n equals minus n, and then when I know that, I can start adding things to the s string. Here do while loop, using a do while loop. Do s I plus plus equals, let me initialize I equals 0, si plus plus equals the last number, the remainder of 10 of I of n, it is the the last digit in the number n, add that to binary this, and then do this while n divided by equal to 10 is not equal to 0, right? And then if sign less than 0, then I will do si plus 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 equals minus, and sign not si equals null character. Then how do I reverse a string? Reverse. Shit. Or is it str? How do I reverse a string? Let me write my own function then. Void reverse. We'll take in a string s and return the reverse. Int I equals 0, starting from 0, while not while but for I equals 0, initializing it again like a stupid man. Si is not equal to null. Keep the null character where it is, don't mess up with that. And I would also like to know the length of the string. That is crazy. So yeah, after this loop I will have the length of the string. I will point to the null character, then I can do, wait, I don't have to initialize it here like this, and now here int j. For loop I equals j equals 0 while j less than I. J cannot be equal to I, because if j equals to I, then it points to the null character. And j plus plus, what do I do? S char temp equals s j, and then sj equals s. What is the value at the other end? If I am starting with 0, then I should get 4, and my answer is there is 5. So I minus 1 minus j, and then si minus 1 minus j equals temp, and yep, that should reverse a string. Reverse s. Okay, now copy this, go to the top, and here copy this and go to the top there, and do this. Okay, and now time to test it. First of all, I will give it a character string str that is 100 characters long and a number. Let me just directly print it. %s, new line, and what is the string that I want to print? I want to print str only, but after letting it go through the function. This itoa, what is the number? Let's say 100, and the string is str. Let's see. Clang number to string output dot out segmentation fault. That is crazy. How did I manage to do that? Oh, while it is like greater than 0. Was that the cause? Magic was never a cause of uh, while and yes, yes. I guess this should work. Yeah, that was the problem, right? Oh no. What the heck? Oh shit. Okay. Um. mm, This is going good. Making it negative if it is less than 0, and going through this while it is greater than 0, and then checking the sign, and then doing this thing. So okay, this is good, but I think the problem is here. Oh, while si is not equal to no, not equal to null. Okay, I guess. Okay, this is good. Okay, and so the problem lies in one of these functions. I starts from 0 and I keeps increasing till si becomes null. And does si ever become null? Yep, I'm putting it as null right here. And only after that I'm calling the reverse function. And I starts at 0. It keeps incrementing. Am I being stupid here? Nope. I starts at 0, it keeps incrementing and keeps adding the number to the number, keeps adding character after character. Yep. This part gets the last digit in the number n and puts it into the current place, and also keeps decreasing the n here, and then checks if the sign original sign was less than 0, and if it was, then it also puts a negative sign at the end, and after that it puts a null character at the end, and then here this happens. I think problem lies with this. I know. Ah, shit, I don't have my charger here, and the time has been 2 hours. Okay, I guess we'll have to end the stream here, and we will continue tomorrow from these questions, and of course tomorrow we will complete this chapter. So it only took us 2 days to complete this chapter. That is good. Good speech.